So far, this is what has been proved from previous question. Okay, from previous question. So you have to use that to solve this equation. From what you have so far, from previous question, you can have this. You cross multiply. Because this is question B. In question A, we use the substitution x is equal to cos theta to find the solution. So in question B, we will be using x is equal to tan theta because it looks like the formula for triple angle of tan. Now if you cross multiply, you get this. My target is to use the substitution because this is tan. My target is to use the substitution x is equal to tan theta. So I'm going to try to write this so that I can have the tan cube, I have the tan square, I have the tan and the one without tan. Tan theta, tan of the angle. It could be tan of every other thing, but I don't care. But now, x cube, so that is the reason for rearranging it this way. If you cross multiply, you get this. If you open the brackets, you get this, you get that. Yes? And this remains. Okay, this is brought to the other side now. So it becomes negative here and positive here. This is negative, this is going to be positive when it crosses, right? I didn't put it equal to 0. So this is equal to 0. Yes? Now, because of my target, this is just an approach to make life easier. The target is this. Because of my target and the intention that I have is to make sure my tan theta is the substitution tan x equal to tan theta to work. I think Lillian suggested that based on our own solution or approach is going to be this. So I arrange such that the cube comes first, followed by the square term, followed by the term without this one. Then this term does not contain tan theta, it contains tan 3 theta. They are two different things entirely. Does that make sense? So now, if you now compare this to this, now we can only use these provided, of course, this is what we intend to do, just to verify that of course we're able to do it. It means that if we use our x is equal to tan theta, indeed we can compare with this equation, but the implication will be that if x is equal to tan theta, it will be so that our tan 3 theta itself is equal to root 3. Now again, this is x cube, tan cube. This is x squared, this is tan squared. This is x and this is tan. Yes? Now we have our 3 and 3. The only thing that looks different is that tan 3 theta is root 3. Maybe this is just a coincidence, but if you check the second term, you can see again tan 3 theta is root 3 here, and 3 remains 3. So if we use the substitution, the intention of course is to use this substitution so that we can have this. So the question that was being a problematic, that was giving us problem, if I can put it that way, is how do we then solve this to get the 3 values? That day we got 2 values. I think even most people left before we solved for the 2 values. But then, you and I just figured that out now. Now, 3 theta equals root 3. By all students take coffee, that's the first thing I'm bringing out here. Tan will be here or tan will be here. Yes? So, anything here is just itself. Anything here will be pi plus the first quadrant equivalent. So, this is 60 degrees, which is pi over 3. Now, the angle here is not theta yet. The angle here is 3 theta. So, if tan 3 theta is this, then 3 theta will be arctan of root 3. Yes? Which means 3 theta is in the first quadrant or the third quadrant because 3 tan 3 theta is positive. Now, in the first quadrant, this is root, how am I saying root 3? Pi over 3. 60 degrees. In the third quadrant, tan 3 theta will be pi plus pi over 3, which of course is 4 pi over 3 in the third quadrant. Yes? Now, I'm also saying the other possible values will be from the graph of tan that you have just checked online. If you check the graph of tan, it comes this way. So it doesn't touch at the point, right? At 90 degrees, and of course, it is periodic at 90 basically. 90, 180, blah, blah, blah. So now, if you check the graph, you realize that the values you get here, you get the same value at every pi interval. So we say pi, it is periodic, and it is periodic about pi. Every pi gives you the same thing. In the case of sine and cos, we have figured out that it is after 2 pi that you get the same thing. In the case of tan, it is after every pi. So which means whatever, this is tan of 3 theta. So this principle applies to 3 theta, not theta. Because tan has nothing to do with theta, like for, not directly anyway. Okay? So if 3 theta can be this, it means 3 theta will still be all the, pi plus pi plus pi and all that. Okay, so let's see. That said, it means from this, our 3 theta can also be pi over 3 plus pi. It is periodic. Yes? From this, it means our 3 theta can also be pi plus 4 pi over 3. It is periodic after every pi. Yes? And here, theta will be pi over 9. From here, theta will be 4 pi over 9. Yes? From here, this is definitely 4 pi over 9 over 3, so that theta is 4 pi over 9. Yes? And here, this is definitely 7 pi over 3, so that theta is 7 pi over 9. Now, when you checked, you realize that this and this are the same, yes? So, which is why we have 3 values. Pi over 9, 4 pi over 9, and 7 pi over 9, not 7 pi over 3. Okay? So we just, found out the other possibilities. Now, if you decide to add one more, we might be wondering, let's see what happens if we had one more. What if we had one more? If you had one more, you get 3 theta to be equal to 1 more to this,
7
which is 2 more to this, right? So it's going to be 7 pi over 3. That still gives you 7 pi over 9. Let's add 1 more to this and see what happens. If you add 1 more to this, what do we get? 10 pi over 3. 10 pi over 3, yes? And the result would have been 10 pi, yes? Over 9. This is more than pi. And we are always saying we are dealing with arguments such that this is between pi and negative whatever. So our principal argument is restricted to pi. So we cannot consider anything that goes beyond pi.
Doesn't that also go above?
No, it doesn't. This is 4 pi over 9.
Oh, okay.
This is still a fraction of 1. And this is going to be 7 pi over 9 because this is still 3 theta. Eventually, this is going to be theta is equal to 7 pi divided by 9, which is the same as this one.
Oh, okay.
Remember, we are adding it to the first one and we add it to the second one. There are 2 possible values. Okay? If you add it to the first one, you discover that you get the second value. If you add it to the second one, oh, there's another value. Okay, what if we know by the graph that, okay, it's still going to be the same with another interval of pi? Yes? Add it to the next one, you discover you have the third value. Okay, add it to this one because since we are adding to both possibilities, add it to this one, you get a value that is outside the range allowed for principal argument. Okay. Which is supposed to, so which is why the textbook is restricting you to just 3 values as your answers. Okay? I haven't been able to check it. I'm sorry it took this long to actually give you a better explanation. Okay.